Have you ever wanted to write code that is inherently reusable and resilient in Python? The most effective way to do that is through decorators. You must have seen the @ symbol, which works like a magic, right? But today we are going to look at those decorators through the lens of software architecture. Imagine you have a function which is calling an API, and now that API call can fail due to network error or throttling, and then you might have to write the logic for try except block, and then you might also have to write the logic for retry. This will just clutter your code. But with the help of decorator, you can wrap that logic in a different layer that handles the failures automatically without even touching your code, right? It works like a security guard for your logic, which is able to manage the environment around the function, ensuring it stays robust while the function itself stays clean, right? In this lesson, we are going to learn what decorators are, how to write decorators, and then we will build a custom retry decorator from scratch to see how we can start building architectures that don't just run, but actually scale. So let's dive in. Okay, so as I said, that the decorators are nothing but a wrapper to your function. They can take function as a parameter, and then they can return a function, and that's how they are able to alter the behavior of your original function without having you to have a need to change the code of that original function. And how is that possible? Because in Python, the functions are first-class citizens, and which basically means that you can pass functions as an argument to another function. You can return a function from another function. You can assign functions to variables just like any other object, and they will enhance the reusability of your code. They will give you the separation of concern. It will make your code more maintainable and more readable. So let's see this in action with an example. Let's say you have this simple say hello function, right? And you want to add an exciting decorator over here. So let's see over here. So we just wrote a decorator here. What is this decorator doing? This decorator is taking function as an argument, okay? And it has this wrapper function which calls your original function, and it appends these three more exclamation mark to the return value of that function, and then finally it returns this wrapper. So that's your say hello function, let's say. Now let's see this in action. Let's say exciting equal to an exciting decorator, and then say hello. All right, and then we are going to print this. All right, so what have we done? We called this exciting decorator, we passed it the say hello function, and then we stored it in a variable over here. And then we are just printing it. And let's call this. So we are calling this, and now let us see, it just printed hello with the three more exclamation mark. So yeah, that's how the decorator, very simple, right? But this particular syntax is not very useful in real program. You would not want to write your decorators like that. And what is the easier way of doing it? Let's just comment this, and let's just decorate this with exciting decorator. We just decorated this function, and then now we can just run this, and here you go. You wrote this decorator, a pretty simple decorator, and you decorated this particular function with that decorator. Pretty simple, right? So now let's just go and look at some more examples, right? So over here, I have the logger decorator, okay? What is this logger decorator doing? It takes functions as a parameter, and you are seeing some new syntax over here. So this func tool wraps is another decorator. So we are decorating this wrapper also with a decorator, but forget about that. Why are we doing it? In the previous decorator, right, we did not do it. We directly wrote the wrapper. But in this particular decorator, we are using wraps, functools.wraps, and then we are giving that func. We are doing this because what this does is that it preserves the metadata of that original function. And if you have that metadata available, you can use that particular metadata. So that's how this is. The rest of the things are pretty simple. Before calling the real function, we are just printing. Now we are doing few more things here. The real function can be anything, right? It may be a function with no parameter. It may be a function with some named arguments or not named arguments, normal arguments, right? Over here, this is just to demonstrate that you have access to both the args as well as k args. All right. So we decorated this particular function with the logger decorator. And now over here we are passing arg, and here we are passing k arg, right? Named argument and not named argument. And let's invoke this. So what you can see here is that the logger decorator printed the args here, and then in this version it printed the k args over here. So you have access to it. So now you can log it whichever way you would like to in your real application. Another example of decorator here, this is a very common requirements in systems that you want to measure the performance of a particular module or a function. So in this one, basically, before calling the real function, we are calculating the time, and then we calculate over here that how much time it took for this function to get executed. And we decorated it over here with the performance decorator. I wanted to demonstrate one more concept over here, is that over here, we are using two decorators. So yes, it is possible for you to use more than one decorators. And what is going to happen? The logger decorator will kick in, and it will log the args and k args and the name of the function. And then the performance decorator will kick in, and it will basically print how much time it took for it to execute. So let's see this in action. Okay, over here, this is the logger decorator. You could see that which printed the arguments, and this is the performance decorator kick in. So more than one decorators we used in this particular example. And one more thing to notice here is that the logger decorator, it knows that this is the compute sum. Why does it know? Because logger decorator is calling this performance decorator, right? So, but this, because we use this wraps even in the logger decorator, it is able to preserve that metadata. So that's pretty important. All right, so now this is the fun part, right? Here is another example where you have, let's say, unstable LLM API calls, and the call may fail for various reasons, maybe network failure or something else, right? So this particular decorator is for that purpose, that it retries the call if it fails, and it retries it with exponential backoff. Over here, this part of the decorators looks something similar as before, that it has the decorator and then the wrapper, and then within the wrapper you are calling that function. But there is something extra over here. If you can notice, this decorator has this outer function, one more outer function in it, right? And in that you are passing extra parameters. We are passing retries and the backoff, and if the function fails with an exception, then it is going to retry after 1 second, and then after 2 seconds, and after 4 seconds, and so on, depending on the number of retries, right? So that's something pretty useful. And here is our unstable AI call. We are decorating it with retries. And let's just see this in action. So let's run this. Okay, so after 3 attempts, it was successful. Something pretty useful, and definitely you should try to use this in your applications. And next, I have an exercise for you. Imagine that you have, let's say, an API call, and in that API endpoints, you want to, if the endpoint fails, and there is an exception, you want to catch that exception, log it, but to the user, you should not send the real exception for security reasons. You do not want to reveal your internals of your system. So you want to return just 500 error message with the status code of 500, right? So pause the video and use your favorite IDE and try to write this decorator and try to use it in your function and see how you are able to write that. So I hope you have tried it, and I'm going to just show you my version of this particular function. Okay, so let's see here. Let's look at this, my function over here, the add customer. Let's assume this is part of some API, which randomly right now fails. And then on success, it just returns customer added with the status code. Over here, we have this decorator. We are calling the function. If the function is successful, of course, it will just return that in this particular case. And if it is not successful, then it is going to return a 500 error code and with just this custom message over here, and it will log the error in your logs and it won't reveal the error to the client. So that is about the decorators. Now that you have mastered decorator, you have moved beyond just writing scripts and you can start building resilient, reusable architecture. This is the moment you stop repeating yourself and start letting Python to do the heavy lifting for you. So take this AI retry logic, apply it to your most unpredictable functions, and start writing code that's as robust as it is clean. I'll see you in the next lesson.